Here is the answer for the day 1 bell work. You measure the mass of a substance to be 15.85 grams, but the true value is 15.92 grams. Calculate your percent error. When you answer, write the formula, show the substitutions, and give the answer. So here is the formula. Please start by putting that in the bottom box. Now we're going to make substitutions into that formula. So in the numerator, inside the absolute value bars, in place of experimental value, fill in what we are told that we measured, 15.85. And then subtract. Now in place of true value, fill in the 15.92. And then there's an absolute value bar. Then the division line, and in the denominator it's the true value, 15.92. This division will output a decimal number. If we multiply by 100 and put a percent sign, that will convert the decimal into its percent form. From math class, we know that we do the work inside the grouping symbols first. So inside the absolute value bars, let's do that subtraction. The result will be the absolute value of negative 0.07. And close the absolute value bar. And this is divided by 15.92 and then multiplied by 100 with a percent symbol. Next, let's apply the meaning of absolute value bars. They change a negative number into a positive number. So this becomes positive 0.07 divided by the 15.92 and then multiplied by 100 with a percent symbol. We'll take the calculator, do this division, and times by 100. And the result on the calculator screen is 0.4396 with some more digits. But let's think about the rounding. In this math problem, there's division, and one of the numbers in that division has one significant figure, just the 7. The 0 in front of the 7 is a placeholder telling us that's 7/100ths. So only that digit 7 is significant. Our final answer can only have one significant figure. So we'll round this to 0.4%. That's less than a 1% error. We're told that we were measuring something and we got a very small percent error. So we measured very accurately. The technique to find percent error is to find the difference between what you measure in your experiment and what the true value is, the number that a professional scientist would get. If the experimental value is less than the true value, then this subtraction will give a negative number. But when you do the absolute value bars, it will turn into a positive number. If your experimental value is larger than what the true value is, then the subtraction will give a positive result, and when you do the absolute values, that's still a positive result. The number you get by subtracting these is called your amount of error. It's how much different your value is from the true value. To get a percent, you divide the amount of error by the true value and multiply by 100 to change from a decimal into a percent number. In this particular problem, our amount of measurement error was 0.07, and 0.07 out of 15.92 is 0.4%.